Now we'll go through the relational operator in Pig Latin. It's very important, and it's a bit something that it's unique and you should supposed to learn. So give focus from here. So load is a relational operator. What the load will do, it's like a command. Okay, it's like a command. Load is like a command. All the relational operators are like a command only. So load will do what? Load will load some value from the either from the local file system or from the MapReduce file system. I mean the HDFS file system. So it's a relational operator. It will be using in this way. See this. I'll give the direct example. This is the example. This example, if you can understand, then you understood load. So load this particular relational operator you have written. Then you have to write down the path. This is the info actually. It's a file that is required to load. You are going to load this file. This file is in the root, then pig example, then pssplit.txt. So this is the file you are going to load. pssplit.txt. It's in the root and then pig example folder. Inside there the file is there. Using, it's a keyword using. In this keyword is used for a load function. So have you seen that pig storage is a load function? You have seen before. Pig storage is a load function. I'll show you again. 3 load functions you have seen, na? See this. Pig storage. Then you have learned about the 2 others are not that important. Text loader and bin storage. These 2 are not so important. The important thing is that only pig storage, because for this is machine readable format we go through our character folders. That is not so widely used. What we widely use is that this particular function, that is the pig storage. Yes, so this is the load function. It will be used for helping the load operator. How it will help? It will load this particular file psplit.txt based on the value of comma. So inside this psplit.txt there are many comma separated values are there. Suppose 1 comma 2 comma 3. So 1 denotes something, 2 denotes something, 3 denotes something, correct? So when you are loading this particular file, you are checking the commas, and whenever a comma is occurring, we will provide that value to a particular schema values. So the first schema value, that is the schema field value, is A1, which will hold integer, and the second schema field value, I mean the field name, is A2. So there are 2 field names, or the column names, or the property names. You can use these terms. So this is the schema you are defining. That's you are writing as, right? As is used for defining a schema. So this as part is not mandatory. You can write down the load up to this also. Yes, you can just load up to this, or you can use the pig storage and you can load it. But here you are loading with the schema. What the schema you are giving? The schema is having 2 column names or 2 field names, A1 and A2. A1 will be holding integer, A2 will also hold integer. And whenever this comma will be occurring, then A1 will get its value, and then for the next comma A2 will get its value. Then for next comma A1 will get its value, then next comma A2 will get its value, like that. So the value is loaded from the psplit.txt, and if you dump A means this variable, this constant value, the value, we got some value, right, by using the load, that is stored into the variable A. So now if you dump A, that is print A into the grunt shell, then what will happen? We can see the content of psplit.txt. See this, it is given in this way, 3, 2, that's the first tuple. So this is the first tuple, okay? This is the first tuple. A1 and A2 values, 3 and 2. Then next it occurs and the value 1, 8 has come. The next is the value 4, 9 has come. The next the value comes with 2, 6. The next the value has come with 1, 7. Yes, then the next value has come with the value 2, 1. Yes, in this way the values are coming. Next we have the split. The split operator is also very important operator, but not so important like the load. Yes, what the split will do, actually split is use split alias space into, always split and into is all together, like group by is all together, na? Similarly split into is all together. Yes, how it will work? It will split a relation into 2 or more relations. That is split, that the name comes from that purpose. The operator name split has come for that particular reason. It split a relation or table into two or more tables. Yes, based on some given Boolean expression. See this, we're splitting this table. Okay, this table A has been loaded from psplit.txt using this particular syntax and using this particular schema, correct? And we got this data as you have seen in the last example. Now if you want to split this particular relation into two relation, then we'll write down like this: split A into X and Y. You're giving comma, right? Here you're giving this comma, right? So A is actually split into one relation X, another relation Y. How? Based on this particular Boolean condition. What's the Boolean condition? If A1 is less than 2. So A1 is where the A1 is less than 2. This is the A1. This row is the A1, right? This particular is the A1. Now 3, 1, 4, 2, 1, 2. This is the A1 because this is how the schema is defined. And what is A2? The next column is the A2. 2, 8, 9, 6, 7, 1. This is the A2. Correct? So we are seeing based on this condition that A will be this relation A will be split to X if the value of A1 is less than or equals to 2. So the 1, 8 will go to the X, 1, 7 will go to the X, 2, 1 will go to the X, 2, 6 will go to the X. That is satisfying A1 is less than or equals to 2. And if the value of A1 is greater than 2, that is 3, 2, 4, 9, this 3, 2 and 4, 9, here A1 is greater than 2, right? So it will go to the another relation. The name of the relation is Y. Now if you dump X and Y, you can see the difference. See, we are dumping X. So if just we are shown with the dumping X. So if you dump X, then what will happen? We'll get this particular relation, that is 1, 8, 2, 6, 1, 7, 2, 1. 1, 8, 2, 6, 1, 7, 2, 1. I hope that you understood how this dumping works. Dumping shows the results. Now we'll see the next union. Yes, are you clear? It will opposite to the split. It will create the union of two or more relations. We'll see directly with an example. We are loading A here. How we are loading from the p union 1.txt using the same peak storage and using this schema A1 and A2, and we are dumping A. What we are getting? This particular value 1, 2, 3, 4. 1, 2 in single tuple, 3, 4 in the another tuple. Now we are loading B. Dumping B by loading from this particular value p union 2.txt. It has B1, B2 and B3. It is having three values here: B1, B2 and B3. Are you getting? See it. So we are getting, when you're dumping B, we are getting 5, 6, 7 as the first tuple, 8, 9, 10 as the next tuple. Yes. Now if you use the union over here, union A comma B, so you are gathering basically all A and B, both the content of A and B. Yes, so we are getting this result. This is the one of the table is here 5, 6, 7, 8, 9, 10. Another is the 1, 2, 3, 4. We are getting both. Yes, this is what we are getting over here. This result we are getting in this way, dumping the result. So the content of both the tables are there. Now if you want to filter means you want to select the rows only which match to a certain condition. Then we use the filter. How here doing? See here, now this result is now filtered. How we are filtering? Filtering A by A2 is equals to 8. So what is the A? I think here it was A. No, this A will work. So suppose one table is there A. That table A is now filtered with the value A2 is equals to 8. So whenever A2 is equals to 8, we'll only take those columns. I think I can show it by using this particular, right? Yeah, suppose this is a table A, right? If you dump A, you are getting this. So you are taking only this 1 and 8. A2, this is A2, right? This particular rows are A2, right? This particular column values are A2, right? And this particular column values are, look at my cursor. So this particular column values are A1 and this particular column values are A2. So we are filtering based on that. A2 should be equals to 8. So only one A2 will be taken if we dump on this particular A2. Yes, so we are filtering a particular relation based on a particular condition. Yes, so it selects the tuple based on Boolean expression. It selects the tuples from a particular relation based on this particular Boolean expression and will be stored to the result. Yes, now we'll see distinct. Distinct is nothing but elimination of duplicates. Distinct A, if we do, what will be happening? Only the unique rows will be displayed. Suppose one tuple has 1 2 1 comma 2. Another tuple also may have the value 1 comma 2 na. So both the tuples cannot have the same tuples if you use the distinct A. Then in the result only the unique tuples will be displayed. Yes, so unique rows and tuples are same, right? We're using the term rows and tuples interchangeably, as you have seen, as you've observed definitely. Now sample. What is a sample? What is the use of sample? When you sample a particular relation, randomly sampling. Suppose you want to get 1% of data from a particular big relation is there. Suppose you are using sampling. Suppose you want to test a hypothesis, test a theory. So you don't want to use the entire real world big data or big table data. What you do basically, you just want to take 1% of the data from the particular table and do the experiment with a particular algorithm. Then what you'll do, you'll execute a sampling. How will do that? Sample space large data. This is the large data, is the name of the data, name of the table, 0.0.1. Yes, so it will do 0.0.1 percentage of, I mean 0.1, it's 0.1 means what? 1 divided by 100, right? So 1% sampling we are doing, and that will be stored into the another variable, and we're writing the name of the variable, name of the constant, small underscore data. Yes, so in this small underscore data we'll store the value 1% of sampling from the table large underscore data. In this way we can do the sampling using the sample operator. Now we'll go to the for each operator. So you can see here there is a table A. We have done the table, we're getting this result 1 2 3 4 5 6 7 8 9. So first tuple is 1 2 3, next tuple is 4 5 6, and the third tuple is 7 8 9. Now if you use the for each statement on the on A, then what we'll get? We can get A1 and A2 if you write down their names specifically. So as you can see that you can just go through with the columns. A1 and A2 are the columns, right? The field names. Field names are the column names. A1, A2 and A3 are the field names or the column names. Yes, so you are going through A1 and A2. How you are doing that? For each space, the name of the expression where from you are getting it actually, and then generate is its name. Generate is the part of the syntax, okay? And then these are the column names which you are passing. So from these particular lines, you are going through only with there are 3 field names or 3 column names, right? In the schema, A1, A2 and A3, but you are going through only with A1 and A2. So you're getting 1, 2, 4, 5, 7, 8. See, that's why this result is coming. So as you can understand that from this particular example, for each will traverse from the column by column. Now nested for each is also possible. Yes, so inside one for each loop there will be another for each loop. That's it. Similar concept. Now we'll go through the join operators. Suppose there are different types of joins. Okay, I'll just go through one by one. So please be a bit of patience. Hold on and look at it. So one table is there, customer.txt, with this particular values. What the values are in this customer.txt? We have the Ramesh. The ID of the customer is 1 and the name is the Ramesh. Age is 32. City is Ahmedabad, and 2000 is I think the amount which it may have, and all these things, maybe the amount they have. And the next customer is 2, their name is the Killan. Next, 2 is the ID, Killan is the name, 25 is the age, Lil is the city, and 1500 they have. There is another table. Similarly, there is another table, orders.txt. There is the number order ID. Yes, it is done by the customer 3. So who is the customer 3? Customer 3 is Kaushik. Kaushik made this order with the order ID 102. When he has done this order in this particular timestamp. What is the particular timestamp? This is the particular timestamp when you make that 2000 on 8th of October 2009. How much amount he has purchased things and all? 3000. Yes. Similarly, we have the next order, the timestamp of the order, and the which person has done the order and how much amount they have taken. So now these two tables will be used for all the join operations. So I hope that you understood these two tables, right? Customer.txt and order.txt. The two tables are there. Now we'll go through the self join operation. We'll see that how self join works actually. The self join will be joining of two tables. Joining of one table to the same table. Correct? The self join, as the name implies, self join. You are joining yourself with yourself only. Yes. So we are loading what? Customer.txt. We are loading customer.txt and writing into the customer one. Yes, based on this comma. For each comma, says you can see here, for each comma in the customer, it will be stored to a particular schema variable here. So for the first comma will be generated, it will be stored in the ID. For the next comma, it will be stored in the name. For the next comma, it will be stored to the age. The next comma will generate, it will store into the address, and then it will be salary. Yes, are you clear? So as you can understand, when you go through with this particular table, for the first comma is 1 after 1, right? So 1 will be in the ID. Next comma here, so before that what value is there? Ramesh will be in the name. The next comma is 32, so 32 will be the age, and then the next comma is here, so before that element is Ahmedabad, that will be in the city, and there is no other comma. There is the last value over here. Correct? Are you clear? Yes. So it will be stored over there in the I think salary. The last one is salary only we did just now. Yeah, salary. We stored to the salary. Yes, and now the customer, again we are loading the same table in the same way and writing and storing to the customers 2. Now we have to join this. Customer 3 will be the result of join customer 1 by ID. IDs are unique, right? And customer 2 by ID. So for each ID it will give the, so for each ID it will be storing all the value comma with the next value. It is joining now. So by ID it has joined these two values. Now with the ID 2 it has joined. So two things are repeated. See, for each thing it will be repeated. Look carefully. 3 to Kaushik 23 quarter 2000 salary. Then again the same thing repeated. Similarly from 4 from here to 6500, the same thing is repeated, because we are self joining. We are joining the self 1 to 2000. Then we are joining customer to the customer with the ID. So from the ID it will keep on generating. Yes. Now we'll go through with the inner join. Inner join is also known as the equijoin. What happens in inner join? Two different relations will be joined together. How? Based on a condition. See, this is the inner join. We are giving the join operator. First table name is the customer, which will be joined by the next table name, that is orders. How? By a particular IDs, a particular field name. The first field name is used ID for the customer table, and customer ID is used for the next table, orders by. As you know that these two are connected. These two are connected. Let me show you again. These two are connected. ID of customer and order, this particular thing, customer ID of orders are same. That's what these things we have just given the name. See here, just you have given the schema name. Yes, actually you have not shown over here, but customer ID is the third row, the third value of the orders table. That is customers underscore ID. That is which particular, this particular field stores the data of which particular customer make this order. Okay. Yes, and we are dumping the customer orders. This thing we are dumping. So it will be giving this particular result. This customer order will give this particular result. See, only the customers 2, 3 and 4 has made the order. Other customers have not made the order. 2, 3 and 4. Only these customers has made the orders. Other customers are there and they have details in the customers table, but they have not made any order. As you can see, we'll go back to there and we'll show you that which customers make the order basically and which customer has not made the order. See, which customers make the order? Only these customers made the order. I'll just change the number. See, this customer 3 has made the order. This customer 3 has made the order. Correct? And this customer 3 also made the order, and this customer 4 has made the order. That's it. So 3324, these customers only made the order, no other customers made the order, correct? So let me go back there. Yes, so only those customers are coming who has made the order, 2334, and their details are given over here. Other customers has not made any order, so it has been after after joining by using the equijoining, only their details are being displayed. See, this is the name, age, address, and the city and the salary of the customer ID 2. It is joined with order ID 101. Timestamp is this. Customer ID is this, who has made the order, and this is the amount which has been ordered. Similarly, for the customer 3, these are the details after joining. Yes, this customer 3 has made two orders, order number 100 and order number 102. And customer with ID 4 has made a single order with the ID 103. So these things are being joined together based on the customer ID and the order in the customer's table ID and the customer underscore ID in the orders table. Now we'll see about the outer join. Outer join of three types: left outer join, right outer join, and full outer join. Correct? Left outer join, right outer join, and full outer. What is the left outer join? In left outer join, it will return all rows from the left table. Yes, even if there is no matches. Even if there is no matches in the right relation. So two tables will be joined on this condition that all the rows from the left hand side of this join operator will be taken into consideration, and even if there is no match on the right relation. And if there is a match with the right relation, then definitely that will be come out. So we'll see one example with the join. This is the left join. See, check it out. How you are making this the left join? By using this particular statement, left outer join. So in case of left outer join, what will happen? All the things, all the rows in the from the customer table will be considered, even if the ID of the customer's table and customer underscore ID of the orders table are matched or not. And if any match happens between the ID of the customers and customer underscore ID of the orders table, then those will be come up and it will be displayed. So if we execute this thing, then this particular result will be there. If you dump that, see this, all the things are taken right from where? From the left table. As you can see, all the, see, there are 7 particular customers, right? In the, as you have seen the last table, customer.txt. In customer.txt there are seven customers. All their details are there, but only customer 2, 3, and 4 has made. Only customer 2, 3, and 4 has made the orders. So their details are being added here, like the inner join. This is like the result of the inner join, and this is also will be considered. See, these highlighted things, these highlighted lines are the those customers who has made the order. It's like the output of the inner join, correct? Now self join, no, inner join, correct? As you have seen in the last example. But as it is the left outer join, all of the others, rows from the customer table is also taken into consideration. That's why this line with the customer ID 1, customer ID 5, customer ID 6, and customer ID 7 is also being considered. And here it is just space. It means that with the orders table there is no match for the customer 1, 5, 6, and 7 because they have not made any order only. So their ID is not there into the orders table. Yes. Now in the right outer join, it's the opposite thing. The right hand side tables data will be all, that is the orders data, orders.txt. From that particular table, all the orders will be there, even if there is no matching into the other side, the left hand side. Are you clear? So 2, 3, 4 will be there, and if there is another orders with the ID something, suppose 10, 11, and 12. Suppose there are no customers in the customers table with the ID 10, 11, and 12, but they have made the order. Their names will be also there. Are you clear? See here, now we are making it by using this particular syntax. What's the syntax? Right. Wait a minute, I'll show you. That's enough. Outer right. To make it right. Then what will happen? All the lines or all the rows of the orders table will be, because it's the right hand side, right? That will be there into consideration. Even if no match happens with the left hand side table customer. And if it matches, then it will be like inner join. See this now? It is giving the result like the inner join, because whenever there is some order happen, that order made by some customer ID that is available into the customer table. So it is coming with the match. Are you clear? Yes. Now we'll go through with the full outer join. What is the full outer join? In case of full outer join, we'll write down the statement full outer. Here, the rows from left table and the right table, that is the two joining tables, all rows will be into consideration, even if some condition matches or not. So all the rows of the customer table and all of the rows of the orders table will be taken into consideration, even if no matches happens between the ID of the customers and customer ID of orders. Then also it will be given here. So as you can see that it will be same like the last example, because in order tables, all the orders are made by some customer ID which are already available into the customer table. Even if it is not available into the customer table, then also those orders will be taken into consideration over here. Yes. So left outer join, let me just summarize. For left outer join, what will happen? In the left hand side tables, all rows will be considered, even if there is no match with the right hand side. Yes, and if there is some match with the right hand side and left hand side table, then anyhow those will be considered. That is for the left outer join. For the right outer join, what will happen? For right outer join, the right hand side tables, all of the rows will be taken into consideration. It will be printed, even if there is no match with the left hand side tables, condition and the where we are matching with, ID with the customer ID. Now if any match happens, definitely they will be shown over here. And for full outer join, all the tuples, all of the rows of the left table and the right table will be taken into consideration, even if no match happens. Yes, all of the rows will be there. Suppose in the left table 7 rows are there, and in the right hand side 4 rows are there. 7 plus 4, 11 rows will be there. If match happens, then based on the match, it will join the tables and the data. Now we'll see about the group, what it does in the group. For group, what happens, you can see the example here. When you group some table by a particular name, so here we are dumping A. I'm not going to explain this again. So when you're dumping A, we can see that we are dumping with the last name and the name. So Jason Roy, okay, Jason Roy with the ID 1, John Thompson with the ID 2, Chris Roy with the ID 3, Nick Holder with the ID 4. Yes, and we have James William with the ID 5 and Chris Holder with the ID 6. Yes, so these are the data we have into the A. Now if you want to group it by the last name, what is the last name? Roy Thompson, Roy Holder, William Holder. Correct? If you want to group it, then you can write down this particular operator. Group the table which you want to group by a particular field name which is there into the schema. So in this schema, which field name is there? Last name is there. Yes, last name is there. So based on this schema, for this schema's second column name, we are going to group it. So what is the last name here? Roy. So Roy is coming. For the Roy, there are two people, Jason Roy and Chris Roy. So Chris Roy with the value 3 is there as a single tuple, and then Jason Roy, the value 1 is there, the second tuple. So in this particular tuple, you can see we have grouped with the last name Roy. Similarly for Holder, we have two Holder, Chris Holder and Nick Holder. For Thompson, there is only a single Thompson, John Thompson, so only his name is there. For William, we have a single William, James William, the value is there. So we have grouped as per the last name. Roy and Holder got 2 values, and the last two will got 1 values. That's it. Yes, I hope that you understood this grouping. This concept is very simple. Now we have the co-group operator. Yes, you can use the co-group for grouping two relations. In the last example you have seen, we have grouped just a single relation value, right? If you want to group with values of the two relation, you can use the co-group. So we are having two tables, student details and employee details. See, we have the student details table and we have the employee details table. So what we'll do basically over here, we want to co-group that. How will co-group? First we are getting it in the student details, we are loading it and storing into student details. We are loading student details.txt and keep into the student underscore details, and we are loading employee underscore details and storing into the employee underscore details by using the load operator. And how it is, I'm not going to explain. We have used the same strategy as we have used in the last examples. So now we are using the co-group statement. How? Student details by the condition of age column value and employee details also as per the age value. So what will happen when you dump the co-group data? It will take that based upon the age, employees and students will be grouped together. Yes, in the last example we've seen that we grouped in a single relation inside. Here you are grouping with two relations. See here how it will be there. See, 21, for 21 we are giving this particular values, correct na? 4 Priti Agarwal 21, this data, and 1 Rajiv Reddy 21, and this data is there. Yes, similarly for the age 22 we have made the grouping, for the value 23 we made the grouping. Yes, for value 24, for the age 24 we made the grouping, and for age 25 there's a grouping. Yes, so here it is blank, means no value is there from their side, and there is a value for the other side from the other table. Yes, so there is the co-group. What the cross is the operator used for making the cross product of two or more relations. Yes, so customer and orders are there. Now if you want to make the cross product, then you can the same tables, okay, the same tables as you have seen just two examples before. The same tables are used over here. Are you clear? You use the same tables for the join operations, right? So you will be using these same tables for the cross product. We'll make the cross product of these two relations. How it will work? We will write down in this way: cross, name of the relations. That's it. Yes, so see this, how it will cross product. It will cross product in this way. For 7 we are making the cross product. Yes, are you clear? It is getting it in terms of this particular ID, this particular ID. See, check it out, you can understand. Yes, this is the cross product of these two. You can see this ID, you can see this number and the name, you can understand. Cross product, if you don't know the cross product operation, please go through once. It's very easy thing actually. Now we'll go through the order, and we'll stop this. That's enough for this particular basics of pig letter. We have kept up to this, and the next video we'll go through in detail with the practical sessions and all. So what's there here in order? In case of order by, we make order. By default, the order, order by this particular operator does the a particular table is sorted out based on their order. It may be ascending or descending order. Okay, so if you want to make it this particular table, you can see this particular result with the value 5 3 5 2 3 1 3 8, then 9 3 6 6 4 8, then 1 to 5. Correct. Now if you write down the order, this particular value, this is A actually. Okay, we have dumped A actually. So if you want to order A by A1 in descending order, if you write DESC, so we are ordering A by what? By A1. What is the A1? You can see this. What is the A1? The first one is the A1. Yes, the first column is the A1. So 5 1 9 6 1. This is the A1. Yes, so we are ordering it by descending order. So for ascending order, it will start from the lowest to the highest. For descending order, it will come from the highest to the lowest. So start from 9 6 5 1 1. Got it? If you want to don't make it descending order, then you write ASC. It will be into the ascending order. And by default, it is if you don't write ASC also, you write an order A by A1, then by default it will be in ascending order. And then the last one in limit. Limit will do what? It will limit the number of output tuples. How many tuples you want into the output screen. So if you write down limit A space 2, then it will dump what? The first two tuples only, 5 to 1 and 3 to 7. See, it was just dumping 5 to 1 and 3 to 7 from A, but A has 5 different rows, 5 different tuples, but the first two tuples will be taken into consideration. this is the basics about the pig, all about the pig Latin's basic constructs. If you learn up to this level properly, if you have gone through with this particular video properly, then I'm sure that you can start with the pig Latin programming language with lots of good vibe, with a good confidence, and you can basically go through with the pig. So please, if you don't understand any part of this particular video tutorial, then definitely I'll go through with the practical sessions and I'll execute all these things, and from there you can understand very easily. The one part of the pig Latin is not yet covered, that is user defined functions, that will go through with another video. If you I'll give this PDF into the into the description of the video, so that you can download this PDF and you can learn from there, and you can, what are the commands and what are the join operation, what are the things has been provided in this particular PDF, you can just go through with that. You can type into your installed pig, from the pig grunt shell or by any other mean of the pig execution, and you can learn pig Latin programming language by practicing. Definitely I'll go through with the another videos, and I'll go through in detail with the user defined functions, another part of the pig definitely. Okay, if you have any doubt, you can write into the comment section, and please subscribe to the channel. Thank you very much.